Hello, everybody. How are you all doing? I know Vadim made you exercise at the beginning. I'm debating whether I should or shouldn't. But this is probably what your third talk by now, so I think you might be tired. So let's begin. I am Hamad Waqas. I am a DevOps engineer at NGN. My contact details are on screen at the moment. I have a master's in aeronautical engineering, and somehow, some way, I found myself doing IT about 10 years ago. So what actually do IT people do? Many of you here today are either studying IT or in an engineering discipline and have some impressions of what IT people actually do. Some IT pros will tell you that, hey, it's actually related to systems, but that's not really the right way to think about it. Our responsibilities actually begin and end with users. We are in the business of solving problems, whether they be technological problems or human problems, faced by our users through the use of technology. Our users may be relatives at home, colleagues in our organization, or customers of our applications sitting halfway around the world. So let me present to you the state of IT by taking a slight detour through our history to illustrate how we got here. It all started with the first computer some hundreds of thousands of years ago. Now you're thinking, wait, that's not right. Let's explore it a bit further. The first one, or the first database, was a biological entity made of a bunch of neurons and synapses that fire in patterns that allow for inputs to be processed and for information to be stored and later retrieved, to perform calculations, to present outputs in terms of physical actions, plans, hopes, and ambitions. It had some problems, though, which still hold true today, but weren't noticed as of yet in our history. It had limited storage capacity. If it's not clear by now, I'm talking about the human brain. So it had limited storage capacity. It needed to cycle through data periodically in order to make room for new information. And the information that was stored in it was not durable unless it was information related to remembering grudges. It also doesn't have much of an uptime guarantee. It needs about 6 to 8 hours of downtime to perform maintenance every day. And it was also a single user system, which is to say that it could only serve one user at a time. It's not vertically scalable nor horizontally. Vertically scalable means adding more processing power. As far as I'm aware, you can't make your brain more powerful, and nor can you add more brains to your body. And finally, most importantly, I think, we do not have a backup system for our brain. So along with the first database came the first users, and they started noticing problems, and humankind kept coming up with solutions. We start our first technological breakthrough with control of energy, which is fire. This happened a million years ago. Then we move on to the next big step, which was the first external arithmetic engine around 3,000 years ago, which was the Sumerian abacus. It was simply a bunch of lines drawn in sand along with pebbles. Then we move to about 3,000 years ago again, and we have the first tablet, not the iPad or an Android box, a stone tablet with writing on it. This is the first external information storage system in human history. At this stage, a user could look up information at any time of day without having to depend on someone else being awake. Then we finally come to the thing that we recognize as modern computers. This was made by IBM in 1939 and had a keyboard and an electronic display. At first, people bragged about how big their computers were, and they would take up spaces larger than data centers. Then the miniaturization movement took over, and people started talking about how small their computers were. Along the way, humankind went to the moon, and enterprise computing started. Somewhere around this time, the first system administrator was born. We started off with bare metal computing. So now imagine yourself in the 1990s. You're a systems engineer for an enterprise. The world of IT is not yet too fragmented. IT engineers are still somewhat a novelty, and your workspace looks like what you see on the screen. If any of you were around at this time, those are a bunch of old school servers with Windows 3.1. You get a request from your manager who looks somewhat like that and says, hey, I need you to create a new server ASAP. ASAP for business people is a bit different from ASAP for IT people because you know that you have a lot of work to do. You buckle up and you start. You know that this is going to be a time-consuming process and you will not be able to do this very frequently. You perform what is known as requirements gathering, where you try to gather as much information as possible from the users of this new application and from the people who will operate it. You then perform calculations to see how many users will use it so that you can figure out what type of CPU you should have, how much RAM you should need. And then you kick off a multi-week process of calling up vendors, asking for quotations and licenses. You forward all these quotations to your finance department, who eventually, after playing a few games of tug of war, approve it, and you move on to your next step in the phase of your project. Yeah, you wait. You wait for the servers to be delivered. They can take anywhere between 4 weeks to 3 months. Then as soon as they come in, the ASAP part kicks in. And you are expected to do many different things all at once, simultaneously. After they arrive, you arrange for them to be racked and stacked. Then you install the operating system. You ask the network team to connect this to the network and provide you with the network config, which will also take a few days. Then you perform the required config and you install the application, then perform the config for the application. And around about 2 to 6 months after the first request came in, you are able to say, hey, the application is ready. Since this takes so much time and effort to set up a server for getting ready into production, you start developing emotional attachments to them. You agonize about naming servers the same way developers think about naming variables, and the same as when parents try to name a child. Should you use planet names for the basis of your server naming scheme, or Lord of the Ring characters? Should the accounting server be called Jupiter or Gandalf? Each of the servers in your environment now is a snowflake, because only you and you alone know what exactly went on while installing this machine. And if you know anything about snowflakes, you know that each snowflake is unique. If you stick your hand in the snowfall, the ones that you catch in your hand are going to be unique to you. And you have just been part of a human interaction that will never repeat itself. Everyone else doing the same will have their own experience. Similarly, all the interactions that you have with your server are unique to you. You end up with sticky notes on your servers that say stuff like, don't change anything on the server. If it stops working, just unplug the cable, say Bismillah, Inshallah, and plug it back after 10 seconds, it'll start working. No one knows who wrote these notes. Probably some old engineer who's left the company. You treat these pieces of knowledge as scripture, and you have nightmares about being in the server room with no sticky notes on your servers to guide you. There is still no going around the fact that it takes you ages to deliver anything. The time from a request being generated to provide a service to the time you actually provide the service is called, in our industry, time to market, or service delivery velocity. With traditional infrastructure in the 90s, this was far too large. You also hear about stuff like the internet. You read about it in a magazine. You also see something called virtualization, but it is still too expensive for your poor organization. In your quiet time, after dealing with all this hassle, you consider becoming a farmer. Then we move into the 2000s. Virtualization is here. Your, your data center looks like that. You now have Google, you have internet connectivity, and most of the people who will graduated from Ahlia University in 2022 are going to be born around this time. But you don't have time to think about people who don't exist yet. You have work to do and research to plan. You have been given the task to plan the IT roadmap for your organization for the next 5 years. This is a tradition, a cycle that you will repeat every few years. You guess the number of users you will have starting from today up to the next 5 years. You will try to guess how much storage capacity you need to store their information, how much compute capacity you need to serve their requests, and then you double it just to be safe. You kick off the purchase cycle just like in the 90s. You play the tug of war with your finance and the vendors, and then you wait until the servers are delivered. Once they are delivered, you then start the process of creating a cluster. This you do only once every 5 years or so. And this is the advantage of virtualization. For every new request that comes in for a server, you won't have to actually buy one. You will use the previous capacity you have allocated or bought and set up and create virtual machines inside them. So your manager comes in again. Some things don't really change. And they ask you for creating a new server ASAP. This time, instead of going through the whole hardware process, you simply create a virtual machine with the required CPU and RAM and the hard disk space, which only takes a few minutes. You then install and configure the operating system, which possibly takes a couple of days. And you ask your network team to perform the appropriate config on their end, which also takes a couple of days. So now you're serving a request down from months in the 90s to a few days, maybe a couple of weeks. You take this a step further. You say, hey, I'm getting the same type of request every time. So why can't I just create a template for my Windows servers and a template for my Linux servers? You drop down this time for a couple of weeks to 1 week. So now you are able to deliver a service that is 10 times faster than you could do in the 90s. But people are still not happy. You still have a few problems that you need to solve. You end up with performance bottlenecks. In case you did not perform your capacity calculations right, or you guessed the usage wrong, then you end up with scenarios where your users are trying to access your application, but they see it as so slow that they can't really do anything. This happens from time to time, like when sale events happen, like Black Friday, or even student registration times. Another problem that you have is you do not have the ability to recover from disasters. If a fire happened in your data center, it's going to be a bad day for you. Your outage windows are long, and your backup recovery processes are manual. You also have to deal with large capex cycles, whereby you are buying things from time to time, which increase the budget of the department for that particular year. And you can never, ever really accurately predict capacity 5 years down the line. Things change. This is the stage where most of the companies in Bahrain are at. If you are looking to enter a company like this, you will need certain skill sets, like being able to deal with virtualization. The virtualization platforms that are popular are VMware, Hyper-V, and KVM. VMware by far is the leader in Bahrain. So if you're going to choose one, run with that. You also need basic Windows administration skills, basic networking skills, and the ability to Google if you get stuck. The certifications I recommend for you at this stage are VMware Certified Technical Associate, Cisco Certified Network Associate, and a couple of Microsoft certifications. The next phase of IT started a few years ago in Bahrain. We call it cloud. But what is it? This has been a buzzword that has been going around quite a bit. Are they all talking about a collection of water droplets in the sky? Perhaps some are. The IT people, however, are referring to a concept whereby we are not responsible for buying hardware anymore and are simply renting compute capacity on someone else's computer or someone else's data center. But why though? Imagine in your classic scenario. Actually, let's talk about cars. This would be cloud computing versus traditional computing would be as if you were renting a car instead of buying a car. A lot of you would think, why would you ever want to rent a car if you can buy a car? Well, let's explore this a bit further. Imagine you have a classic scenario where you need to go from A to B and you have some money burning a hole in your pocket. So you buy a two-door shiny red sports car, you're happy with it, but you have to fuel it weekly. You have to maintain it every few months. And if something goes wrong, you are left without a car for a significant period of time, just like in IT, if there was a fire in our data center. Other problems you face are perhaps when, let's say you get married. Now you have another seat. Well, your sports car can accommodate that. But when you have a child, your capacity is no longer sufficient. Unless you had predicted your family size years ago, you would not be able to deal with it at the stage. That means you need to sell this current car, buy a new car. Since these type of changes happen very rarely, and they used to happen very rarely for IT, it made sense for us to buy hardware and then periodically assess whether the hardware is enough for us or not. Now let's just skip past to a situation where you're planning a road trip with your friends. Let's say there are 20 of you. Are you going to buy a bus for just one road trip? Probably not. You're just going to rent it. You're going to rent it for a few days, pay for that, and then bye-bye bus. This is the ability that the cloud offers to be able to use as much capacity as you want when you want it, pay for it, and then be done with it. The main players in this market are Amazon Web Services, also known as AWS, Azure, which is from Microsoft, and Google Compute Platform, sometimes shortened as GCP. I put Amazon Web Services as bold because it is by far and large the most popular cloud in Bahrain. If you're going to pick one thing to learn, this is the thing that you should learn. And if you want to start off with it, I suggest a certification called AWS Cloud Practitioner as a starting point for your cloud journey. It will at least get you through your CV through HR departments. This isn't to say that the other cloud providers are not worth learning though. We touched upon the benefits of cloud by talking about cars and buses. Let's talk about it a bit more. One of the major planning burdens an IT department has is capacity planning. You want these to happen very infrequently because the time to acquire hardware is far too long. So your projections also need to be as correct as possible so that it allows you to maximize the investment in your hardware. However, no one is correct all the time, and new information may come to light down the road about unexpected user or application behavior that requires you to add more capacity, i.e. buy more servers slowly and painfully. Cloud providers allow you to bypass this. If you need a compute or storage resource that is beyond your initial projections, you can simply create a virtual machine with a few clicks of a button and have it up and running within a few minutes. It removes the burden of capacity planning from IT departments. and we can provision and deprovision resources quickly. It also provides our business with increased agility. Instead of dealing with a 3-month cycle before a new service can be introduced, we can potentially bring up new services in minutes or hours. This means that our business can compete for users far more effectively than others. Another important aspect of cloud computing versus traditional computing is the trade-off of CapEx to OpEx. If you're not aware, CapEx is capital expenditure. You take a big chunk of money at the beginning, you buy something, and then the next few years after that, you're not really spending much. OpEx is instead of spending that big chunk of money, you spend little bits of money over time. The companies in Bahrain tend to fit in to two cloud architectures. One is fully cloud, where they stop buying hardware altogether and they just move all of their infrastructure to a cloud provider. The other one, which is a bit more popular, is that they maintain a presence on data centers and a presence in cloud. And they use cloud to burst capacity when user demand increases. For example, there are also regulations that prevent fully cloud institutions. For example, financial institutions related to payment systems cannot have those systems on cloud yet. It will get there, but not so far. Bahrain has a really interesting strategy in this regard. The Bahraini government a couple of years ago adopted this cloud first strategy, whereby they will evaluate every workload that they need to deploy, whether or not it can move to cloud or not. If it can be in cloud, then they will go with it. If it can't, only then will they consider buying any hardware for it. And the cloud that Bahraini government has adopted is AWS. So if you are looking for starting a career in the government, AWS, again, is the thing that you should learn. Many of the organizations in Bahrain are at this stage where they have some infrastructure in AWS and some infrastructure in Azure, some infrastructure in the data center. So at this stage, the stuff that you need to learn for going into a company which is multi-cloud is your Windows administration, your network administration, your virtualization as before. But we also add a new requirement for having basic understanding of AWS and basic Linux administration. One of the most important things you can do for yourself as an IT professional is to learn Linux. This separates you out from the crowd straight away. There are very few Linux administrators in Bahrain, and because of their rarity, they do tend to earn a bit more than Windows administrators. So certifications that you would like or would want to pursue these are the usual ones from before, which was the 365 Microsoft fundamentals and the desktop administrator parts, the CCNA, the VMware. But here I've added the AWS certified cloud practitioner, which we talked about briefly before. This will give you a good brief on why people use cloud, how they use cloud, and give you an idea of the services AWS offers. And then there is another certification for Linux that is important, which is the Linux Foundation Certified IT Associate. It gives you a primer on how Linux works and basic scripting along with it. Then we now move to the future, for Bahrain at least. Many other nations or many other organizations that are far more developed tend to have already adopted DevOps and automation, but this is still quite a new thing in Bahrain. And this is the part where we do not expect new people to already know these things, but having bit of knowledge of this stuff sets you apart from the others. What is DevOps though, anyway? DevOps is the combination of cultural philosophies, practices, and tools that increases the organization's ability to deliver applications at a high velocity, evolving and improving products at a faster pace than organization using traditional software development and infrastructure processes. This speed enables organizations to better serve their customers and compete more effectively. That is too long. I'll try to simplify. The word is a combination of developer and operations, a system administrator who can code, or a developer who can administer systems. Traditional IT organizations have siloed departments, which means they will have a network team, they will have a security team, they will have a Linux team, a Windows team, and blah, blah, blah. So any request that comes in for creating a new service has to go through each of these departments turn by turn, which takes time. And not every department has the ability or the willingness or the appreciation of the other department, which creates walls, which creates slowness in terms of the ability to service user requests. DevOps aims to solve this problem. It's a philosophy which combines all these skills from various different departments into one individual or one tightly knit team. As the name indicates, it's just a lot of coding. Actually, we should talk about what a DevOps person does. In short, we write code to provision or deprovision services automatically. Imagine our previous problem of dealing with surges of traffic from users. Let's assume a relevant example. Let's say it's registration week for you. Students rush to grab the subjects they want for the semester. If this is an IT department in the 90s, and they would have to anticipate this surge months in advance so that they could order the compute capacity, set up the servers, and basically ensure that everybody remains happy. In our case, let's assume that this wasn't anticipated. As a result, the service slows down to a crawl. The IT department gets notified, hey, users are not able to access the application, or it's just too slow. Then the IT department starts the process, the painful process of ordering stuff, setting up stuff, which we know is going to take months. So this registration process is gone. The users who were part of this pool are going to remain with negative memories of this experience. Let's assume now that this same problem is happening in the early 2000s, where we have virtualization. And we also assume that the capacity was not anticipated by the IT department. So users come in, log in, try to get to their registration for their specific subjects. Since many people try to do this at the same time, service slows down to a crawl. The IT department gets notified, but because they don't have to go and purchase servers, they can create virtual machines. So this time it takes a few hours for them to bring the service quality back up while they add new services. So this is still a time where at least some users had a negative experience. Now let's look at this problem through the DevOps lens. We architect our services right from the very beginning to deal with any load scenarios and to deal with any failure scenarios. We leverage cloud providers monitoring methods to see if the CPU utilization is too high. This metric gets checked, for example, every minute. When the users start trying to register, the CPU cycle starts to go up slowly. Let's say when it gets to 70%, we trigger an alert saying, hey, it is possible that there will be congestion. Let's boot up a server. An automated script creates a new server, adds it to the pool, and then users still don't notice anything. Let's assume that it increases again past 70%. Another server will get added, and so on and so forth, until there are enough servers to deal with the demand from the users. And when the users start going away, when they're done with the registration, all these servers start getting killed one by one in an automated fashion until only one server remains. That is the power of DevOps, or the power of DevOps and automation implemented correctly. Similarly, if an application stops running or stops responding to user requests. The traditional idea over here would be, hey, so someone's going to call you as an IT person in the middle of the night, and you're going to have to run to your data center and try to fix the problem. If you've implemented automation, then whenever a failure is detected, an automated script will just create a new server from the last known backup and kill the existing server, and nobody will know anything. So to get to this type of job or this type of knowledge base, you need to understand a few different things. In a very basic context that we have discussed today, the tools that allow you to orchestrate or create such environments where automation is possible are Terraform and CloudFormation. If you are only dealing with AWS, then CloudFormation is your logical choice. But I recommend Terraform, as you can manage multiple cloud providers as well as infrastructure on-prem. Then we come to another class of tools, which are config management tools. So if you think that orchestration tools create virtual machines, then config management tools configure the operating system and the application inside that virtual machine. In this space, we have established players like Ansible, Chef, Puppet, and SaltStack. I recommend Ansible because it is the easiest to start with, and it's quite easy to learn too. Another thing that I want pretty much everybody to understand is Git. This is just a version control system. A version control system, if you're not aware, is something that keeps track of the history of a file over time. So for example, if you change a word or a line, it will know that it was changed by Muhammad Waqas or Ali Abdullah at this time, and whoever else approved it. And while we are at the subject of code and developers, let's just quickly talk about what is required for a developer to enter the market. Traditionally, Bahrain market didn't really have a lot of space for developers. Our economy was based on a lot of buying applications from outside and servicing them here or deploying them here, which meant that our job market was very system administrator heavy rather than developer heavy. Over the past few years, a lot of organizations have seen the benefit of having developers on staff so that they can create customized applications for their own use case. So they don't have to buy stuff from outside, which may not fit their use case as well. So to get to being a developer, you need to know a few programming languages. The most popular programming language in Bahrain still is PHP. There's a lot of PHP going on. There's also C Sharp with the .NET frameworks. And if you are going to choose one language which will last you for the duration of your career, then I think it should be Python. It has taken over IT, not only in the sense of development, but also in terms of system automation, and also for other engineering disciplines. So if you are a mechanical engineer or a data scientist, you will most likely touch Python sometime during your career. Similarly, on the front-end side, you have your old traditional HTML, CSS, and JavaScript. You definitely need to know your version control system, Git. If you're going to choose a JavaScript framework, then I think you only have React, Angular, and Vue as logical choices. In Bahrain, React is a bit more popular, but there are postings for Angular. So it's not something that you should not be surprised by either framework. You should have a bit of knowledge on both. On the database side, if you're going to pick one, I think it should be MySQL. As a starting point, it is easy to learn. It's free. You can deploy it, and you can get away with SQL queries in it that will also be applicable for other databases. On the mobile development sphere, you have React Native and Flutter. If you are going to bet on only one thing, then I think it should be Flutter. Flutter has this thing where you can create applications for Android as well as iOS with a largely the same code base. And you can take the same code base to create applications for Windows, Mac, Linux, and the web. The Mac, Linux, Windows, and web part is still in beta, but I expect that over the next couple of years, Flutter will take over the world in terms of application development. With that, I'm gonna stop my presentation, and thank you so far for listening. And if you have any questions, please shoot.
أستاذ محمد يعطيك العافية وما قصرت.
All right. Thank you, guys. Bye-bye.